So, good afternoon, everyone, and welcome to this lecture. We are in lecture number 17, and we are dealing with, I think, the relation between electrostatic field and electrostatic potential. And in the previous class, we had seen how we can find the difference between two potentials or potential difference between 2 points if electric field is given to you. We can use this vector equation, which you will hardly require anywhere, but if so, you can use this vector. You can use this vector equation, dot product equation, or more of the time you will be encountering cases where electric field is going to be uniform, and then you will have to find out potential difference between any 2 points. So I think we have done questions on this. Now if you have a question on this, which you can see right now, in the previous class, we had seen to find out how do we find out the potential difference between these 2 points. Now, apart from potential difference, there could be other questions also that could be asked. For example, if I ask a question here like this, I move a charge from E to B. I move a charge from E to B along this straight line. I move a positive charge plus Q is moved from E to B along this straight line. Then the question could be, what is the work done by the electrostatic force in moving this charge from E to B? This is a subordinate question that could be asked. So how will you find out the work done by electrostatic force to move this charge from point E to point B? Yes, so I'll give you 2 minutes to tell me the answer for this, because they might not simply just ask you the potential difference. There could be a question where they ask you the work done. I'll give you 1 minute to do it. Do it fast. As you see, we don't have the luxury of time. Time is a luxury that we don't have. So let's not waste any single moment of the same. Yes, bacha.
6, sir.
6, sir. How did you get this, sir? 6, sir. How did you get this 6 as answer, sir? Yes, there has to be reason. You did not obviously do akkad bakkad bombay wo, because there was no point of, there's no option to do akkad bakkad bombay wo. How did you get the answer?
Work done from E to B is work done from E to A plus work done from A to B.
Okay, so work done from E to A plus A to B. Okay, what is the work done from E to A?
0.
What is the work done from E to B? What is the work done from E to B? Yes, you can also do it this way. Not a problem. Yes. How did you get the work done from A to B? Boys, girls? No one?
-10.
-10. -10 joules. Is that so?
Yes, sir.
Okay. How are you supposed to do this? Work done from E to B. You can write it like this, and I hope you remember it. It is the charge Q multiplied by potential difference VE minus VB. You just have to find out the potential difference between E and B. And you must know that potential difference between E and B is same as potential difference between A and B, which we have already calculated as plus 10 volts. So the answer is plus 10 multiplied by Q. Don't forget this Q, because otherwise the answer would be dimensionally wrong. So the answer would be plus 10 Q joules would be the work done in moving this charge from E to B. That is how this has to be done. Now I think both the classes online. Do we understand this? Everyone? Do we understand this, everyone? Boys, girls?
Yes, sir.
Boys?
Sir,
Do we understand this? How this is done?
sir, VE minus VB, why it is equals to VA minus?
VE minus VB, why it is equal to VA minus VB. We did the same question in the previous class. Do you remember what were these arrows that I drew? What were these arrows that I drew? What was the meaning of this arrow? Does anyone remember what was the meaning of this arrow? Boys?
Equipotential.
What do you mean by equipotential?
Electric field is uniform.
Yes. What else? Electric field is uniform. That means equipotential surface. Who told you that? Equipotential surface means electric
Potential
field
is same, sir.
potential is same, sir. Yes, sir. So VE minus VB will be equal to what? Potential of point A. What were you doing in the last class? Were you absent in the last class, beta? You absent in the last class. They are at the same potential. So VE minus VB will be VA minus VB. Is it difficult to understand?
Yes, sir.
Difficult to understand or you have understood?
That's it.
Okay. Remember these simple things. I mean, we can't come back to the same concept 10 times because we are short on time. Anyways, I hope everyone understood this. Yes or no? How you are supposed to find out the work done, because they may not simply ask you the difference in potential. Let me make another question here. Let me put a charge, let us say 4 microcoulomb. Let us say minus 4 microcoulomb here. And then I move it from point C in this path to point E. So I move it like this. I again ask you the same question. What is the work done to move this charge from point B to point E by the electrostatic force? Can you now give me the answer for this one? This is how the charge is moving. It is moving in a fancy way. It is moving in a fancy way. Yes. Can we now have the answer of what is the work done in this case? I'll give you a couple of minutes. I hope everyone has understood what we discussed in the last class. We all remember that, no? VA, VB, yes or no?
Minus 36 microcoulomb joules.
Minus 36 microcoulomb joules. Does it look like a correct unit? Microcoulomb joules? Does it look like a authentic unit? micro and coulomb and also joules. हाँ बच्चा.
Minus 36 into 10 to the power of minus 6 joules.
Yeah, now it looks better. I think that would be the answer. Anyone having any doubt?
No, sir.
Minus 36? How did you get minus 36? How did you get minus 36? I don't understand. Minus 36. No. Hey Bhagwan. It feels like the last class has gone down the drain and it is now floating in some Ganda Nala, ready to get submerged into the sea. The last class has gone down the drain. Is that so?
Minus 32, sir.
Why is everyone getting 30? That is my doubt. Why is everyone getting 30? What's the reason behind it? I fail to understand. Why is everyone getting 30?
Sir, minus
Yes,
20.
32. Yes. I thought I was looking at some other value. Okay, so how are you supposed to get do this? Sorry, it's my fault, I guess. The class has not gone down the drain. Thank God. I have gone down the drain. So how do I do it? I multiply this by the minus 4 microcoulomb charge. Remember, the answer will be coming in microjoules. Multiplied by the potential difference between VB and VE. And what is the potential difference? Point B is at a higher potential, point E is at lower potential. The difference, the distance is 4 and the value of electric field is 2. So 4 into 2, 8. So minus 4 multiplied by 8 microjoules. That should be your answer. Minus 32 microjoules. Why I'm writing mu? Should be micro. Okay, I can write mu for micro. Microjoules. That is the answer. Do you understand how this is done? In the previous class, we had found out the potential difference between the points. Do we remember that class that happened yesterday? This question is from the same class, beta. I'm just moving a charge, nothing else. Do we understand this?
Yes, sir.
Boys, I don't see conviction. The conviction is missing. Do we understand this?
Yes, sir.
Pakka?
Pakka, sir.
I don't see the conviction behind this. I see a lot of confusion and a lot of question marks around each and everybody's faces. How? I see a lot of hows and not a lot of happy faces. Is that so? Lot of hows? How? How? Okay, let me try and get what? Try and get a problem from the previous years. Maybe that would give us much needed confidence. What type of question come? Let me see if there is a question. Ta ta ta. Na na na. Na. ये जो है, this is okay. This is these are the three questions. So nothing much I have to play around. So what I have here to play around. I don't have a diagram wala question, but I have this question. The unit is wrong, so I can't give you this one. I can't give you this one. Anyways, let me give you from here. From here. Where is the question? Gone. Question has disappeared. Now, where was that question, man? Here. Seems like no question has come from this particular thing. Anyways, there's a question here. So, I think you would be able to do it. You should be able to do it. Okay, try this one. Oops, I have to make it much smaller. Okay, this is the one only I found in yesterday's paper. This is, I think, 2021. Two thin coaxial rings of radius A having charge plus q and minus q are separated by distance s. The potential difference between the center of the rings is. I think we have done a question exactly on the same line. The only thing was I had given both charges as positive. They are given one as positive and the other one as negative. Can you find out the potential difference between the 2 points? अभी बनी को जाना Find the potential difference between the centers of the two rings. Will you be able to do this? Yes, beta.
Doing so.
Should not take so much of time, sir. You should be able to do it faster, sir. We've done a similar question. I think we did a question which was much tougher than this one. Let me just refresh your memories. This was the question that we did. Same question has been asked. I gave you 2 minutes to do it.
Option D, sir.
Option D, sir. It has taken a lot of time, but I think the answer is correct. Option D. How do you get this? You call this point as A. You find the potential of point A. How do you find the potential of point A? It is KQ by A. Potential due to the first ring minus KQ upon under root of A square plus S square. The distance is given as S. This is potential of point A. The potential of point B will be minus KQ by A plus KQ by root over A square plus S square. You can now just subtract VA minus VB and get your answers. Yes or no? We understand this? And I think you will land up with the fourth option, option number 4, VA minus VB. Now remember, this might not be the only question. They could put a charge and they could ask you, what is the work done? You know how to do this. They could put a charge and they could ask you, what is the kinetic energy of the charge? You also know that part. Yes or no? We understand this? Do we understand how this is done?
Sir.
Understood.
Okay, so this was how do we find out potential difference from electric fields. Now, if you remember, there was a question given to you. This one. You had to find out the potential difference between the V1 and V2. And you had to find out the potential difference between V3 and V2. All of you told me that potential of this plate 3 will be more than the potential of plate 2, and plate 1 will be more than plate 2. Now is the time that you tell me what is the potential difference between 1 and 2. Now, this is the most difficult question that can come in a JEE. If you can do that, that means you are doing good enough. Now, how are you going to do this? Remember, whatever we have learned, you have to put them together, get your answer, and stay happy. I'll give you 2 minutes to think about this. Anyone can tell me how are you going to do this? How are you going to find the potential difference? Yes? Anyone? So, what you got to do is you got to find the electric field between these. Can you find out the electric field at point 1 and electric field at point 2? What is the electric field at point 1 and electric field at point 2? This is the green plate, this is the pink plate, and this is the blue plate. How do you find the electric field at point 1? This green plate is going to create field in this direction. Yes or no? Yes or no?
Yes, sir.
How much will be that field? How much will be that field? No one knows it. That is the reason that we are not able to solve it. What is the field created by infinite sheet? We have forgotten it so early. Remember, your exam is still 4 months from now. If you can't remember, if you forgot it after 4 days, what's going to happen after 4 months? What is the field created by a sheet?
Sigma by 2 epsilon naught.
So sigma, how much is sigma for this sheet? 2q is the charge divided by A, that is sigma, divided by 2 epsilon naught, that is the green field. It is in this direction. Then you find out the blue field. How much is the blue field? It is in this direction. Charge is Q divided by A divided by 2 epsilon naught. That is the blue field. That is the pink field. Then you find out the blue field. How much is the blue field? 3Q by A divided by 2 epsilon naught. So then you find out the net field. How much is the net field? 2Q plus Q on the right, 3Q on the left. So the net electric field between these two plates is 0. Do we understand this?
Yes, sir.
Electric field between these plates is 0. That means what is the potential difference between A and B, or 1 and 2? The potential difference between 1 and 2 would be 0. Do we understand this? Yes or no? Now let us find out the potential difference between plate number 2 and plate number 3. For that, we need to find out the electric field. The green field will be going in this direction away. The value of this green field is 2. The value of this green field is 2. What has happened? 2q by A epsilon naught. It is going away by 2 epsilon naught. Sorry. The value of this pink field, it is coming towards q by 2a epsilon naught. The value of this blue field, which is going away by 2 epsilon naught. What is the net field? 2q is going here. 4q is coming here. So the net electric field will be in which direction? The net electric field would be in this direction. Yes or no?
No.
How much? Q by A epsilon naught. Yes or no? That will be the net field. Do we understand this? 3q plus q is 4q. 4q minus 2q is 2q. 2q divided by 2 epsilon naught. Q by epsilon naught. Now you can find out the potential difference between 3 and 4. What will be the potential difference between 3 and 4? Electric field, which is uniform, multiplied by D. Q by A epsilon naught multiplied by D. And this is how questions of this type are done. Do we understand this? Anyone understands this? So, to find out the potential difference between two plates like this, and this is one of the tougher questions that can come in a JEE, whether it is JEE Main or it is JEE Advanced, one of the tougher questions. And this is how it is done. Everyone understands this?
Yes, sir.
So, this is all that you need to remember or know about finding out electric potential difference from electric field. Now we will do the reverse of this process. What do you mean by reverse of this process? To find out electric field from V, you will be given V as a function of something. V would be given as a function of X, Y, and maybe Z. Potential would be given as a function of all these things. What you got to do? You have to calculate field. You don't have to understand how this comes. You just have to remember that this electric field is minus of del V by del Xi plus del V by del Y of J plus del V by del Z times K with a negative sign. What is this del? Anyone has heard about this del?
Partial differentiation, sir.
Partial derivative. You know partial derivatives? Yes or no?
Sir.
Bas. That's good enough. That is good enough to solve any question. That is good enough. Can I give you a question now straight away? Huh?
Yes, sir.
V is given as minus 5x plus 3y plus root over 5z. Can you find out? This V is given as a function of x, y, and z, my dear friends. Can you find out the electric field vector from this information that is being shared with you? Just have to do simple stuff. And you end up with your answer. Simple things. Nothing complicated, my dear friends. Yes, bacha. Is there any answer coming from anywhere? That I can look forward to? Any answer appearing from anywhere?
5i cap minus 3j cap minus root 5k cap.
Yes, that is absolutely correct. We just find the partial derivative and electric field will become 5i minus 3j minus root 5k. Everyone understands
Sir.
this? Yes or no? Pakka? Pakka no?
Yes, sir.
One more just to check you. Potential is given easy. Remember, this is not a problem of physics. This is a problem of maths. Find the electric field for this scalar function. You have 2 minutes to show your talents.
Minus 2xy minus z, sir.
Huh? It had to be a vector, bacha. What you are saying is not a vector. So it cannot be the answer.
Minus
I'm
of
waiting. Yes.
minus of 2xy I cap plus x square plus z j cap plus yk cap.
That looks better. Electric field is the partial derivative. So I take minus out. Del V by del X. Only X is the variable. Rest all are constants. So the first thing becomes minus 2xy I hat. Everyone understands this? Partial derivative. My dear friends. Boys. In the same universe we are.
Yes, sir.
Wandering in some other. Okay. Then I differentiate this partially with respect to y. Y is the only derivative. Y is the only variable. Rest are constants. So it will be x square plus y, or x square plus z, that will remain j hat. Then I differentiate this entire thing partially with respect to z. Z is the only variable. Rest are constants. Plus y times k. This, my dear friend, is the electric field vector. Do we understand this? Yes or no?
Yes, sir.
Okay. So this is the general way of finding out the electric field vector from your potential functions. We call this, gentleman, which is in pink, as the potential function. And from there we have calculated the electric field. The same question could be put in a different way. Instead of this potential function, you can have the function of potential energy. Now this question can come in electrostatic, this question can come in gravitation, this question can come in work, power and energy. You could be given a potential ki jagah energy function, and from there you are supposed to find out the conservative force. This is the same question. Do we understand this? Yes or no? So I can write, like, what can I write? I can write the conservative force F vector as minus del u by del xi, same thing you have to do, plus del u by del y of j plus del u of del z of k. Do we understand this? Yes or no? This is what I am finding. This is, I am finding the conservative force from the energy function. Both are the same things. We understand this? Yes or no? No, yes. Huh?
Yes, sir.
The next heading, my dear friends, is what? Equipotential surface or equipotential line. Equipotential surface or equipotential line. We have already seen what is an equipotential surface. Yes or no? Do we know this? Do we remember equipotential surface?
Yes, sir.
What is an equipotential surface?
Potential is equal.
If at every point the potential is same, the surface is known as, or the line is known as, equipotential surface or equipotential line. Yes or no?
Sir.
Equipotential surface or equipotential line. Yes or no? Now, what you got to remember? About equipotential surface. The first point that you must remember, electric field is perpendicular to equipotential surface. Do we know this? Do we know this? Yes or no?
Yes, sir.
Electric field is perpendicular to an equipotential surface. Electric field is perpendicular to an equipotential surface. What type of equipotential surface are created by various type of charge distributions? What type of equipotential surface would be created by various type of charges? What type of equipotential surface a point charge will create? Tell me. A point charge will create spherical equipotential surface, because at any point on those surface you can see electric field will be perpendicular and all points on that surface would be equidistant from the point charge, and therefore the equipotential surface will be concentric spheres. This is also the case with a spherical charge distribution. If the charge distribution is uniform throughout the surface equipotential surface would be spherical in shape. Do we understand this?
Yes, sir.
Yes or no?
Yes, sir.
Does this remind you of something that we have already done?
Wavefront.
What, sir?
Wavefront, sir.
Wavefront, sir. A point charge. The waves are going like this. And this is the wavefront, the shape of the wavefront. So whatever question is a question of equipotential surface, it can also be asked as a question of wavefront. The second type of charge is a line charge. And the type of equipotential surface would be cylinder. Do we understand this? At any point on the cylinder, electric field will be going perpendicular. The points will be at the same distance from the line charge. They would be equipotential. Do we understand this? Yes or no? Yes or no? No or yes? Huh?
Yes, sir.
Any uniform electric field, or for that matter, the field due to an infinite charge, surface charge, is uniform. Wherever you have uniform electric field, uniform electric field, uniform electric field, uniform electric field, the equipotential surface would be planar. Do we understand this? Yes or no? No, yes. Huh? Oh, this has gone above our head saying bye bye, sir, bye bye. Bye bye. Do we understand this, bacha? Have you drawn this? Have you drawn this equipotential surface? Okay, the next thing is equipotential surface can never cross each other. Why they cannot cross each other? Because if they cross each other, you can draw two directions of electric field, which is not possible. So equipotential surface are never going to cross each other. Do we understand this?
Yes, sir.
One more important point, surface of a conductor. Surface of a conductor will always be a equipotential surface. And that is why electric field is always perpendicular to the surface, whether it terminates on the surface or it emerges out from the surface. Remember those diagrams that I had shown you, electric field coming out or terminating on a conductor, and we had seen that electric field terminates perpendicularly. Why does it terminate perpendicularly? Because the surface of a conductor has to be equipotential. Do we understand this? Surface of a
Yes, sir.
conductor has to be equipotential always. We get this, yes or no?
Yes, sir.
We get this, yes or no?
Yes, sir.
Why is everyone so less in energy? Now, one thing that you can now understand. Everyone is there?
There, sir.
Okay, I think my screen sharing has paused. So I will again try it, start it, and I'll give you a question and we will be discussing this question in the next class. Up till now, what we had done is we had calculated potential difference from electric field. Now what we are going to do in the next class is, if we know what are the equipotential surfaces, can we find out the electric field from that equipotential surface? So we will see that in the next class, that is tomorrow. So I'll continue this class tomorrow and we will solve this question. Equipotential surfaces are given to us. We will try to find out the electric field from this equipotential surface. See you in the next class. Take care. Bye bye.